Okay, so today we're making two parts, this hitch magnet, which should go pretty quickly, and this axle peg, which will kind of be tough. Let's start with the easy one. So I am going to open up my my toy train document. Let's see, I've got my hitch peg and my smokestack in here. So what I'm going to do is I'm going to use the plus sign down here to add a new element. I'm going to add a new part studio. And I'm going to rename this part studio to be Hitch Magnet Studio. And I'm going to make my my sketch on the front plane. So I'll click front plane, make a sketch, push in, and then I'm going to hide the original planes. And then let's look back at what we're doing. We're going to make two circles, dimension them to be 0.25 inches and 0.45 inches, and then we'll do an extrude of 0.25 inches. So we'll start with by drawing the two circles, then we'll accept that sketch and do the extrude. So I'm going to grab my circle tool, starting from the origin. And you can actually do this if you, right when you click to place the circle, if you just type in 0.25, bam, it puts the dimension on for you. .45. So here is my sketch. I got one circle with a diameter of 0.25 and one circle with a diameter of 0.45. So I'm going to accept that sketch. Then I'm going to do an extrude. I'm going to select that outside ring there, and the depth will be 0.25. So our depth was 0.25, the inside circle is 0.25, the outside circle is 0.45. So we have the hitch magnet here. All we're going to do is change or assign a material. So assign material. And for this one, I'm going to type neo. The only magnet material I know of in here is neodymium. And this is supposed to be a magnet. So neodymium, accept. And then I'll change the appearance to be that. All right, so now I've got my hitch magnet. I'm done with this one. Now we can start on the axle peg. So the axle peg is going to be a lot like the hitch peg that we did, where we drew the cross section and then revolved it around. So I will, our cross section here will be, this little chamfer we'll do at the end. So we'll just start with like a cylinder here. So that would just be like a horizontal line coming out and then a long vertical line coming here. And then we would have a horizontal line coming out and then a vertical line coming up and then an arc coming over to here. Then a horizontal line coming over there to be the flat top of the bolt. So I'm gonna make a new part studio. I'll rename it to be axle peg. And then I'm gonna make this one on the right plane. Wait, do I want to do that? No, I want to do the top plane. It really doesn't matter, just the orientation that it'll end up in matters. So I'm just gonna pick the top plane and sketch. I'm gonna hide the other planes, push N to get normal. And now I am going to draw like the cross section of this bolt. I'm going to start at the bottom and then work my way up. So I'm going to be starting down here, but at the origin down here. So this bolt kind of looks like, oh, I need my line tool. We've got the bottom of the bolt. So we would come out kind of horizontally. Then we would need to go up. So that will give us like that's the long part of the bolt. So now we need the head of the bolt. And then there was this little vertical part. And then we need an arc. Well, let me do the other lines. We have a line coming from here. This will be the center line of the bolt that we would kind of revolve around. And then we need a horizontal piece for the flat top of the bolt. And then we need an arc going between these two. Get my arc tool. And just be careful when you're placing the arc that you don't put any constraints on it, because we don't want any tangent constraints on either one of those, because we didn't get told to do them. So we want to place it somewhere where we don't have automatic constraints being generated. Okay, so now we have like the general shape of the cross section. We're going to start putting some dimensions on it. So let's look back at the picture to figure out what our dimensions are going to be. So right here where it says quarter 20 UNC by 1 inch. So this means that this bolt is a 1/4 inch in diameter, so 0.25 diameter. There's 20 threads per inch, and the bolt part, the threaded part, is 1 inch long. So we need the diameter of this to be 0.25, so 1/4 of an inch, and the length of this part to be 1 inch long. So if we come back over, the length of the threaded part would be the length of this line. So I'm going to put this dimension to be 1 inch. And then the bolt part, the threaded part of the bolt down here, is supposed to have a diameter of 1/4 inch. So in order to do a diameter measurement, I need a construction line. I'll put it up here. I'm just going to make a vertical construction line. Got to make sure it's vertical. And then to do a diameter measurement, I will click on that line and then the construction line. So that will give us the distance between them. But if we move the cursor over here, it'll give us a diameter measurement. And the diameter was supposed to be 0.25. I'm going to move this down here so that it's not blocking anything. All right, now let's look back at the picture to see what other dimensions we can put on here. Let's see, the outer diameter of the head of the bolt is 0.422 inches. So we can put that diameter measurement on there now. So that would be measuring from here to the construction line, and then going to the other side to make it a diameter. So click here, click on the construction line, and if we go to the left, that gives us a diameter measurement, and it was 0.422. All right, now let's look back at the picture to see what other measurements we can put on here. This right here, the SR 0.236, that means spherical radius. So this part here has a spherical radius, which means if we can just set the radius of the arc to be this measurement, and then when it gets rotated or revolved around, that'll make its spherical radius. So the radius of our arc should be 0.236. And what else do we have? This right here is information about the hole here. So it's a hexagon socket, and the measurement is 5/32 of an inch across flats, and the depth is 0.111 inches. We're not going to make that right now. We're just making the overall shape of the bolt, and then we'll cut that out with an extrude later. But we can do this. We know that the diameter of this top flat part needs to be 0.25. So that's going to be another diameter measurement. So that would be from this point to the construction line, and that would be 0.25. And now you can see that if we try to move, the only thing that moves now is like the height, the overall height of the bolt. So that's going to be the dimension that we need to put on there. There might be a couple. I think this one here moves too. So we need to know the length of this little line here, and we need to know how tall the bolt is overall. All right, so over here we've got some measurements. So 0.031 is going to be the height of our little line. 0.031. And then 0.125 would be the measurement from the top flat part to the bottom of the head of the bolt. 0.125. So measuring from here to here is 0.125. And now all of our geometry has turned black, so everything is defined. That means we can accept our sketch. And now we can use the revolve tool. The face or region that we're going to revolve is this guy. And the revolve axis will be this construction line. And now you can see we've got like the overall like shape of the bolt. Now we just need to cut out the hole in the top and do a chamfer on the bottom. If we were using Inventor, we would there's a setting where we can tell it what the threads are, but Onshape doesn't have threads. So we're just going to ignore the threads because we would probably just push it on anyway. Okay, so next, let's make the hexagon and cut that hole out. So this is 5/32 of an inch across flats. So what we're going to do is we're going to make a hexagon. There's a tool that makes a hexagon, and you can either make it using a circle inscribed in it or a circle circumscribed about it. We're going to do the one where the circle is inside, because then the diameter of the circle would be the distance between the flats. So I'm going to come over here. I'm going to select the top surface, and we're going to make a sketch. And the polygon tool here, if you hit the drop down, you can choose between inscribed and circumscribed. We're going to do inscribed so that the circle's on the inside of the polygon. So you click first to place the center of the circle, and then your second click, and I'm going to go ahead and let it be this vertical constraint, and I'll click there. It already says 6. So it looks like wherever you move the mouse right here, it'll add sides. So we just want 6, so I'll click. So this has 6 sides, but I want the distance between flats to be 5/32 of an inch, right? 5/32 of an inch across flats. So that means that the diameter of the circle should be 5/32 of an inch. So here's how I'll do that. Got my dimension tool. I'll just click on the circle. And that the diameter of the circle should be 5/32. And all I'm going to do is write 5 divided by 32. When I hit enter, it does the calculation. It gives you the approximation of 0.156. But if you double click on it, if you double click on it, it reminds you that it's still exactly 5/32. It's just displaying a decimal approximation. But you can see that since I had the vertical constraint there, and then I put the diameter on the circle, this is fully constrained now. So we can accept the sketch. And then we're going to do an extrude. But we're going to remove material. This is the shape that we want to cut out. But the depth is only going to be 0.111 inches. 0.111. And so the cut will only go that deep. Accept. And now we've got that part on the top. So then the only thing left for us to do is put this chamfer on the bottom. And this chamfer is given by an angle and a measurement. Angle and a distance. 45-degree angle, distance 0.03 inches. So I am going to select the chamfer tool. It says equal distance. I need to change that to distance and angle. Distance was 0.03 and the angle is 45 degrees. And the entities to chamfer would be this circle, or you could just click on the bottom face and it'll do that same circle. And then you will, okay, rename this axle peg. And then assign material, the ABS. And we can make it some color that we like.